Now we will discuss about pressurization unit. Okay, so as we have seen previously, this is one of the chilled water network. Okay, where you have a different major components like chiller, pumps, AHU, FCU. Then you have a different component. So this pressurization unit is one of the major equipment. Okay, to maintain system pressure in the entire chilled water system. Okay, so here I have prepared one of the lecture. You can go through. This is a lecture I will be sharing with everyone. Expansion tank design guideline for chilled water system. Okay, this is also available in the internet, but I have just shared. I will be sharing with everyone to understand how to calculate the chilled water expansion tank. Okay, so this is as per chapter 13 as per ASHRAE guideline. Okay, so if you go to expansion chamber, okay, this is ASHRAE guideline. 2020 ASHRAE handbook HVAC system and equipment. So in this you will find chapter 13 expansion chamber. Okay, the expansion chamber serves both thermal and hydraulic function. Okay, normally whenever there is a reduction in the pressure, okay, or increase in the pressure, your pressurization unit can satisfy the required pressure. Okay, so by doing expansion and contraction. Okay, clear, right? Okay, so now if you go into this chapter, okay, in this chapter 13, you will find the different type of expansion tank. Okay, one is the open type and one is the, here it's given, one is a closed type. Okay, one is a open tank, another one is a diaphragm tank. Okay, there are three types. Closed tank with air or water interface, this is the equation. Then the next one is the open tank with air and water interface. The third one will be the diaphragm tanks. Okay, so if you go through this lecture, you will understand. Okay, what is a system requirement. Okay, so determining an expansion tank for a chilled water system is essential to handle the thermal expansion and contraction of water as its temperature changes. Right, the expansion tank absorbs the increase in volume and pressure that results when the water in the system is heated. Hence, a step-by-step guide on how to design an expansion tank for a chilled water system. Okay, so what is the requirement? You need a volume of the system, you need the operating temperature, you need the system pressure, okay, you need the fluid types and properties, then you require the static head of the system. So these are the system requirements, right? Okay, now you can able to see here, expansion tank is used in a chilled water system to accomplish three main tasks. Okay, one is the thermal expansion of the chilled water system, and one is the positive to maintain positive pressure at all points. The third one will maintain net positive suction head. Okay, so to maintain this three parameter, you require a chilled water system. Okay, if you don't maintain pressure in the system, then you will have a lack of coolings. Okay, if you have increase in pressure, then there is a chance of leakage in the system. So you should understand both the increase in pressure or decrease in pressure because of the change in temperature, right? Okay, then so this guide will cover the complete expansion tank types, everything. So you can see that there are three type of expansion tank. One is open type, one is a closed tank with no bladder, and the closed tank with a bladder. Okay, so the open type will be, you can see the one of the picture from the internet. You can see this open tank will mostly likely not to be used in HV system because this is not for the closed system. Our chilled water system is the closed one. So this particular pressurization unit will be open to atmosphere. Okay, so that is not suitable for HV system. Okay, the second type will be the closed tank with no bladder. So say for example, this is the expansion tank. Okay, the water and the metal parts in contact. Okay, so say for example, this is the air, this is the expansion vessel, and off of the tank will be the water, and off of the tank or some portion of the tank will be air. Okay, so whenever the pressure in the system increases or decreases, that will expand or contract, okay, within the system, right? But here there is a chance, there is a chance of the water is directly contact with the metal particles. Okay, so then there is a chance of corrosion. Okay, and also when you do the equation, your system capacity will be higher than the diaphragm type. Okay, the third one will be the closed tank with the diaphragm type. Diaphragm type means inside there will be diaphragm. Okay, so it is a pre-charged diaphragm basically. Okay, if you go with the manufacturer, right? Okay, so this is one of the type, the open tank. Second one is the closed tank with no bladder, and third one will be with the diaphragm. Okay, so that is the third type. So you can see the equation for the open type. This is basically the to calculate the expansion vessel volume. Vt equal to multiplied by Vs multiplied by V2 by V1 minus 1 minus 3 alpha delta T. Okay. So here it is given, detailed explanation is given here. What is V2 by V1 minus 1? So V2 by V1 minus 1 is nothing but it describes the change in system volume. Okay. Whenever there is a system volume, so that describes. So this V2 by V1, how this equation came. Okay. And the 3 alpha delta T describes the change in piping volume. So there is a piping volume due to the expansion. So that is the purpose of this equation, right? So we are going to see that what is the system volume changes and what is the difference in what is the system volume changes and what is the change in pipe volume due to expansion. Okay, so that the equation describes based on that. So Vt equal to multiplied by system volume multiplied by V2 by V1 minus 1 and in the whole bracket minus 3 alpha delta T, right? So this to calculate the open system. Okay, but anyway, we are not using in the HVAC system. Okay, then the closed with no bladder, this is the equation. So the Vt minus Vs multiplied by V2 by V1 minus 1 and minus 3 alpha delta T divided by atmospheric pressure by P1. Okay, here also the explanation is given. Pa by P1 minus Pa by P1. This describes the change in pressure that can be accommodated at the expansion time. Okay, so here there is no pressure difference because it is open to atmosphere, but here it is closed, so you can have a difference in pressure, right? When the system increases, then the water will be the expansion vessel will be full of water that increase the pressure. So you have a high pressure and low pressure. So that is why you have a Pa. Pa is nothing but atmospheric pressure divided by P1 minus Pa by P2. This term describes the change in pressure that can be accommodated in the expansion time. Okay, but if you see the open tank, there is no pressure change can be accommodated. The open tank fills as the water, but once the tank is filled, an additional volume can overfill the tank. Okay, so here there is no pressure difference, but here there is a pressure difference because of the closed system. So that is why we are taking the difference in pressure. So that terms is nothing but change in pressure that can be accommodated at the expansion time. So this is the equation, right? So this is the general equation for the expansion tank. Okay, but due to the technology with the different manufacturer, they introduce the bladder. Okay, because the water should not touch directly on the metal part. Okay, because there is a chance of corrosion. Okay, then there is a chance of the larger size of the expansion vessel. To reduce the size of expansion vessel, what they did, they have introduced the pre-charge diaphragm. Okay, so that you have a pre-charge inside the system so that your size of the expansion vessel can be reduced. Clear, right? So that equation you can see here further down. Vt is nothing but Vs system volume multiplied by V2 by V1 minus 1 minus 3 alpha delta T divided by 1 by minus P1 by P2. Okay, so the P1 by P2 is nothing but pre-charge pressure between the system in the system, right? Okay, so now you can see in the definitions. Okay, Vt is nothing but expansion tank volume, Vs nothing but system volume, V1 is nothing but specific volume at low temperature, and V2 is nothing but specific volume at, sorry, this is actually high temperature and this is low temperature. Okay, alpha is nothing but low linear coefficient of thermal expansion, delta T is nothing but higher temperature minus lower temperature. Okay, then the P1 is pressure at low temperature and P2 is the pressure at higher temperature. Okay, so this is the way to calculate your system expansion vessel size. Okay, so I have shared one of the sample calculation sheets. Okay, here you can see this is one of the calculation sheet. I will be sharing the Excel sheet to everyone. Okay, and this is based on diaphragm type closed expansion tank. So this is what the tank we are using in our all chilled water system. Okay, whenever in our system. Okay, because we are not using open type, which is not in HVAC industry, and the other type is a direct type. Okay, so that air and water type we are not using it. So we are using diaphragm type closed expansion tank to reduce the size. Okay, in the system size. Okay, if you do calculation with the other type and this type, you can see the difference in system volume. Okay, so that will give you the larger size because it is not pre-charged. Okay, if you do the pre-charge, then the system entering into the system, it can accommodate more pressure. Okay, say for example, this is your expansion tank. Okay, and this is the piping. Okay, now say for example there is atmospheric pressure here. Okay, so what will happen when the system expand? Okay, if it reach above the atmospheric pressure, what will happen? It can able to accommodate inside the tank. So you require a larger tank. Okay, but if you do the pre-charge, what will happen? Say for example, the normal atmospheric pressure will be 14.5 psi. Okay, so if you do pre-charge at 2 bar or 3 bar, what will happen? Till 3 bar, there is no contraction or expansion, right? So your size of the tank can be lower. So that is why the due to the technology, the manufacturer introduced diaphragm type closed expansion tank, which you can reduce the size of the tank. Clear, right? So now you can see the equation. Vt is equal to Vs multiplied by V2 by V1 minus 1 minus 3 alpha delta T. Okay, divide by 1 minus P1 P2. Okay, and also I can show you from the manufacturer, or sorry, from the catalog, you can able to see the system volume, okay, at different temperatures. This, if you Google it, you will get temperature, so specific volume at different temperatures, right? So that specific volume you have to use it in this equation. Okay, you have a specific equation at different temperatures, right? Temperature point 1 to say for example 360 degree. You can able to calculate what is the specific volume at so and so temperature to so and so temperature. You can able to get this value from this chart. Okay, and also thermal expansion for different materials. Say for example we are using uh, say galvanized pipe or mild steel pipe, right? Depends upon the material, you can able to see what is the linear thermal coefficient in the pipe, right? So this also required to apply in your equation. Okay, so if you go to in your equation, you can able to see the volume of the tank. You are going to calculate. So you require volume of the system, which you can calculate in the entire chilled water circuit by using what is the water volume required to cope up in your system, right? And what is the lower temperature, which is the supply of the chilled water system. Okay, what is your lowest temperature, which will be the chilled water supply temperature, which is say 6.7 as a standard temperature, right? And the higher temperature will be the ambient temperature, which is 35 degrees Celsius. Okay, if you go to as per ASHRAE standard, it is 35 degrees Celsius, but you can able to apply your higher temperature as per local conditions. Say for example in UAE, which is 46 degree, you can able to apply 46 degree. Okay, so this is the temperature, lower temperature and higher temperature, right? And the atmospheric pressure, you know, which is 14.7 psi. Okay, this is the atmospheric pressure. Okay, then what is the infill pressure, which is the system pressure? When you do the pump head calculation, okay, you will do the pump head, right? So that is the infill pressure. Say for example, if your pump head is 5.3 bar or 5.5 bar or 3 bar, whatever the pump head, you can able to put that value. So that is the minimum pressure. And what is the maximum pressure? Say for example, normally you will operate your system at 1.5 times, right? If it is like you heard about PN10 or PN16 or PN25. So that is the maximum pressure. Okay, if it is a PN10 or PN16 or PN25 will vary, depends upon where you are going to locate your expansion vessel. If say for example some of the project you might have seen, the expansion vessel is located on the top of the system. Okay, may say for example your chilled water plant will be in basement, but your expansion vessel will be in top of the system, because that static head also will affect on your expansion vessel. Okay, if you go with the basement, you may have to go with the PN25 with a larger expansion vessel, but if you install on the top of the system, okay, you may have to go with the PN10 at a lower size. So that is why the maximum system allow pressure also required, right? So that is the maximum pressure. Okay, so you have to see what is the pressure. Okay, then the absolute pressure at higher temperature, okay, which is nothing but P max plus P2. Here the equation is given and you will add together. Okay, so the specific volume of water at low temperature, you can go to the table, you can get the value for the lower temperature and higher temperature. Okay, then for alpha, for linear coefficient for thermal expansion for the steel, you can able to go to the catalog, depends upon the material, you can calculate what is the alpha value, right? So if you apply all the values in the formula, Vt is nothing but, say for example system volume 85,000 gallon multiplied by 0.01612, it is a lower specific volume, right, at lower temperature. Okay, minus divide by specific volume at lower temperature and higher temperature by lower temperature, minus 1 minus 3 alpha. Alpha is nothing but 6.5 the e power minus 6 multiplied by delta t, right? The delta t will be 95 minus 44 divided by 1 minus the pressure, which is maximum pressure will be 91.2 divided by P1 by P2 basically. Okay. So if you apply all this value, you can able to calculate what is the expansion vessel. Okay. Then you can choose whether you want to go with one number, two number, three number. Say for example, the calculated is 4858. Okay. You have to choose three number of expansion tank like 1500, or say for example, 5000 divided by 3 approximate whatever the capacity, you have to design it so that it will give you the number of expansion tank. Clear, right? So how to calculate expansion vessel calculation based on ASHRAE? Is everyone clear? Hitesh, respond.
Yes, sir. Clear,
Yeah,
sir.
you got idea, right? Like this is based on ASHRAE chapter 13. There is a equation. There are three types: open type, then there is a closed type with direct contact with air and water. There is another type called diaphragm type. Okay, and
Hmm.
if you go with the open system, which is not used for HVAC industry, so that system is obsolete. And if you go with the closed type, there is a two type available. You can able to go with the two type as well. Okay, but if you go into the market based on the technology, they have introduced a pre-charged expansion vessel, right? So the pre-charged means it will not allow till that pressure. Say for example, if my pre-charge pressure is 2 bar, okay, or 3 bar, what will happen when there is a system expansion or contraction? What will happen? That will not allow into the system into the extra pressure into the system. So that will lower the pressure, lower the size of the pressurization vessel. Okay, that you can see completely in my lecture. Okay, there is one guide I have attached which I have extracted from the internet. You can able to read that guideline. Okay, whatever I explained, it will be the same. Okay, you have three types, and one type will be if you use that here there are three equations. Okay, and the based on the latest technology, we are using pre-charged expansion vessel. So this is the equation. Okay, if you apply all the value, expansion tank volume. Okay, to calculate expansion tank volume, you have to calculate system volume, then specific volume from the table, linear coefficient based on the different material, then that high temperature, low temperature. Okay, high temperature will be the ambient temperature, lower temperature will be the chilled water supply temperature, and you can calculate pressure at low temperature. So the pressure at low temperature will be equal to chilled water head pressure, and at higher temperature will be the maximum pressure considering the static height and considering the static height and the system pressure. Okay, like whenever you do the chilled water system pressure, you have operating pressure which will be like 1.5 times of the system pressure, right? So that is the 1.5 times you will do the testing, right? Remember, whenever they do the testing at site, they will do the testing at 1.5 times. Okay, so that is the maximum pressure. So you will consider that pressure. So that is the difference in pressure and difference in temperature, then difference in specific volume. So if you apply all the values in the calculation sheet, you can able to calculate expansion vessel tank capacity. Okay, clear, right? Does anyone have doubt?